So today we're going to do another set of the math modeling with sinusoidal graphs. So this will be day 2 of this. If you want to turn to your notes, more notes, 4.8, math modeling. So another Ferris wheel problem, okay? Ferris wheel problem, as you ride the Ferris wheel, your distance from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts, your seat is at a position shown in the figure. We don't know which seat it is. It doesn't really matter. We're going to base it off of the data they give us. When the last seat is filled and the Ferris wheel starts, your seat is at a position shown in the figure. Let t be the number of seconds that have elapsed since the Ferris wheel started. You find that it takes you 3 seconds to reach the top, 43 feet above the ground, and that the wheel makes a revolution once every 8 seconds, and the diameter of the wheel is 40. We want to sketch a graph. We want to write an equation, either a sine or cosine, and then we're going to answer the question based off of our graph and our equation. So looking at this, I'm going to just put in some values here. I'm going to get a green here. I know that the high of this is going to be 43, so I'm just going to draw that in, and I'm just going to write a 43 here. Now, I know that the diameter is 40. Okay, so let me draw that in. So I know from here to here is 40. Okay, so that is 40. So what that means is if this is 40 for the diameter of the Ferris wheel, and the top of the Ferris wheel is 43 from the ground, that's going to make this piece to the ground, that's going to be 3. Okay, that's going to be 3. So my low is going to be at 3. The high is at 43. 2 ways to do this. Okay, since we have the diameter here, which is 40, we know that it's going to be 20 up and 20 down. That's going to be my radius. So when I split this through the center here, it's going to be 20 above the 3 and 20 below the 43. And so whether I add 20 here, I get 23. If I take 20 from here, I get 23. Now, sometimes, whoops, didn't mean to do that. Let me get that back. Sometimes you may not know that diameter. So another way is to actually average these. If you take 43 and 3, add them together, which is 46, and divide by 2. So that's my high, my low, my middle. Okay, so let me just start by drawing that. So this is going to be in seconds. This is going to be in feet. Okay, feet above the ground. Okay, so that's feet. Again, my high is 43 and my low is 3. So let me draw my 43. I'm going to draw my 3. I'm going to draw it above a little so I have some room to write my numbers. Okay, so that's going to be my 3. My center, okay, is at 23. Okay, so again, this will be my vertical shift. My amplitude is going to be 20. Okay, now let's get my X going. So it says, or T for time. It says that at 3 seconds, you're going to reach the top, which is 43. So I'm going to put 3 here, and I'm going to put a point up at 43. Let me get a little bigger. Point up at 43. Now, I know that it takes 8 seconds for 1 revolution. So what that means is our period is going to be 8. So period is equal to 8 seconds. So what that means is if I'm starting here at the high, at 3 seconds, I'm going to go 8 seconds beyond that. I'm going to be at a high again. So that's going to make it be 11. Okay, so again, I'm adding the period, the 8 onto this, and I'm going to be up at my high again, which was 43. Now, halfway in between, okay, and halfway in between this, if I average 3 and 11, I get 14. I divide it by 2, I get 7. Halfway in between is going to be my low. Okay, so I'm going to be at 3. And then halfway in between each of those, so if I average my 3 and my 7, I get 10 divided by 2 is 5. And over here, if I average my 7 and my 11, I get 18 divided by 2 is 9. Now this happened to be odd numbers, so you might have been able to see those numbers, but that's how you would do it if it's different types of numbers. Again, average them, add them together, divide by 2. So I'm going to have at 5, I'm going to be at the middle, which is 23. And at 9, I'm going to be at the middle, which is 23. And remember, this is a curve. So remember how our sine graph goes. A lot of times when we start doing cosines, a lot of people have been trying to give me these. It's not absolute value graph. It still curves. And there you go. So since I'm starting at a high, I personally would write this as a cosine. If I'm starting at the middle, you can write it as a sine. So if you want to start at the middle, at 5, you can do a sine. I'm going to start the high with a cosine. Okay, so my equation is going to be y equal 20, and it is a positive 20 because it's starting at the high, cosine. Now for my b, or my frequency, I'm going to use my period to help with that. So I know 2 pi over b is the formula for period, and that is equal to 8. So when I cross multiply and solve here, I'm going to get 2b over 8, 2 pi over 8 equals b, which is pi over 4 equals b. So I'm going to have pi over 4. Now, I mentioned this in past videos that if we have our b being a pi, your x-axis will be scaled by numbers, not in terms of pies. Okay, we're still in radians. Okay, we're still going to use our calculator in radians, but I'm just not going to have pi labeled here. Okay, now my start. My high is at 3, so this is going to be x minus 3. And then we shifted it up to 23. Be careful. A lot of times people want to give me the 20 because you go, oh, I'm going 20 above. That's your amplitude. Where are we shifted to? We're shifted to 23. That's our equation. So now it says, what is the lowest you go as a Ferris wheel turns, and why is this number greater than 0? So we see down here that the lowest it went was 3, right? 3. So the lowest it's going to be is 3 feet. And they're asking, well, why does this number have to be greater than 0? The Ferris wheel would crash if it was not greater than 0. Okay, we did a wheel, a water wheel the other day that was in the water, and that could go below, okay, our x-axis. This one, if we're going below our x-axis, we're going to be hitting the ground. Okay, so next problem. So this is a steamboat problem. Mark Twain sat on the deck of a river steamboat. As the paddle wheel turned, a point on the paddle blade moved in such a way that its distance d from the water surface was a sinusoidal function of time. When his stopwatch read 4 seconds, the point was at its highest, which was 16 feet above the water surface. And the wheel's diameter was 18. And it completed a revolution every 10 seconds. Okay, so this one is going into the water, so I need to go below my x-axis, okay? So let me just kind of draw this. So let's see, we know that the high is at 16. we know that the diameter is 18 for this. So let me get my high. Okay, the high here, let me draw that in. My high is at 16. Okay, again, this is feet, should have labeled that. This is going to be feet above the water, and this is going to be seconds. Okay, now I know that the diameter of the wheel is 18, which means that it's going to be going to -2 as a low, okay, because I need to be going 18 below this. So we're going to have our low at -2. I'm going to kind of drop it down just so I can get my numbers written above it. Okay, so this is going to be at -2. And couple ways I can do this. One way is I know that the radius would be 9, so I can go 9 above this, which would put me at 7, or 9 below this, which also puts me at 7. Or I can average 16 and -2, add them together, I get 14, divided by 2, I get 7. So any of those situations are going to give us 7. So 7. Okay, so now we know that the stopwatch read 4 seconds when the point was at its highest. So I'm going to put 4 here. Oops, put that back. Put 4 here. And that's going to be at the highest. So that's going to be at 16. And we know that it completes 1 revolution every 10 seconds. So if it's 1 revolution every 10 seconds, that 10 seconds, that's going to be our period. Okay, so if I'm here at 4 seconds, then 10 seconds further, which is going to be 14, I'm going to be at another high. And then halfway between these, which if I average these, that would be 18 divided by 2 is 9. I'm going to be at my low. And halfway between these, so that would be 13, and half of 13 is 6.5. Let me write it, let me zoom in for a sec. Okay, so again, what I did, was I added these together, 13 divided by 2, 6.5. I added these together, 23 divided by 2, 11.5. So that's where those values would be. And so at 6.5, I'm going to be at the middle. At 11.5, I'm going to be at the middle. And I'm going to draw my graph. Okay, there's my graph. And now I'm going to write an equation for this. Okay, and again, I'm going to do cosine. I'm going to start here. If I want to start with sine, I could start the sine here or here at the middle. I can also start a cosine at the bottom if I really wanted to, but I'm going to start here. So I'm going to write y equal, my amplitude is going to be 9, cosine. Now for my b, I have to remember my period was 10. So let me just do that math real quick. Okay. So if my period is 10, I'm going to have 2 pi over b equals 10. I'm going to cross multiply. I get 2 pi over 10 equals b. So my b, I can reduce down to pi over 5. Okay, and that will be my b, my frequency. And then I'm starting this at 4. So this is going to be x minus 4. And then I shifted it up to 7 plus 7. So that's my equation. Now here, they want us to figure out how far above the surface it was at 5 seconds and at 17 seconds. And actually, I'm going to put 5 seconds in here, and then I'm going to put 17 seconds in here, okay? So I'm just going to put that in my calculator. So I'm going to be doing, and you need to make sure your calculator's in radians. Okay, we're dealing with radians. So 9 cosine, or sorry, yeah, 9 cosine. And I'm going to do alpha y equal, get my fraction. I'm going to do pi over 5 parenthesis. And we are going to do 5. Okay, so I'm going to go 5 minus 4. Close my parenthesis, plus 7. And I end up with 14 point, let's say 28, okay, as my answer, 14.2, okay, 14.28 feet. So now I'm going to do the same thing. I'm going to put in a 17 though now, okay, so I'm going to steal this again. I'm going to come over here. I'm going to put a 17. I'm going to put a 1. And then I don't want to hit in my 7 or it's going to get rid of my minus. So I'm going to hit second and delete, and that will insert. And then I can put in my 17, and I end up with 4 point, let's say 22, okay, 4.22. Okay, so I've got my 4.22 feet. Now on C, it says, what is the first positive value of time at which the point was at the water surface? At that time, was it going into or coming out of the water? Explain. Okay, so I'm going to put it into my calculator, okay, into the y equal. Okay, so into my y equal, I typed in the equation, okay, being careful of my parentheses. I'm going to hit window, okay, hit window. And I'm going to adjust my window so it looks like this graph, okay? So I adjusted it. I needed to go from 0 to 14, but I wanted to go a little bit on this side. So I did -5 to 20. So I kind of went beyond both sides and I just said by 5s. Now I had to get down to -2 and up to 16. Again, I don't want to stop at -2. So I went a little below -5 and I went a little above my 16. So I went to 20 by 5s. And now if I hit graph, I'm going to have my graph. Now, if we want to see where it crosses the x-axis, I could have put in y equals 0 and find the point of intersection. But another way to do it on these graphing calculators, if I hit second in calc, which is where I could also find intersect, but right now I don't have another line for it to intersect. 0 is your x-intercept. So I can hit number 2. And then what it's going to ask me for is a left bound and a right bound. So this is about where the 0 should be. I'm just going to go to the left of it. I'm going to hit enter. It did a little faint line you can see here. And then I'm going to go to the right of it. Okay, and I'm going to hit enter. And you can see another little faint line there. Hit enter again and again. And then it gives me my answer, 0.08 about. Okay, so we're going to write 0.08 seconds. And it wants to know if we were coming in or going out of the water. So here we were below the water because the water is here. Okay, so we were below the water. So we were coming out of the water. If I was coming down here, this would be going into the water. So I'm coming out of the water. Coming out of water. Okay, so this is another problem. Extraterrestrial being problem. So researchers find a creature from an alien planet. Its body temperature is varying sinusoidally with time. 35 minutes after they start timing, it reaches a high of 120 degrees Fahrenheit. 20 minutes after that, it reaches the next low of 104 degrees Fahrenheit. Sketch a graph of this, write an equation expressing temperature in terms of minutes since they started timing. So let's get a picture going here. So my high is going to be 120, my low is going to be 104. This will draw on my high of 120. And this is going to be temperature over here, okay, temperature, right. temp. And over here, this is going to be minutes. Then the low is going to be at 104. So let's just say that this right here is 104. And this is one where I don't know, like a diameter or a radius. So I'm going to average these together, okay? So I am going to take 120 plus 104, and then I'm going to divide it by 2, and I'm going to get 112. Okay, that's going to be my center. And now I'm going to use these values. I know that at 35 minutes after they start timing, it reaches a high of 120. So I'm going to put 35 here, and I'm going to have a high of 120 degrees Fahrenheit. 20 minutes after this, so 20 minutes after this, which would put us at 55 minutes, we're at a low. So it took 20 minutes to get to here, so it means it's going to take another 20 to get back up to the next high. So 20 more than that will be 75, and that's going to be my high again. Now halfway between these will be my middle, okay? So if I take 35 plus 55 and divide it by 2, I end up with 45. And let me just squeeze that in real quick. So again, I averaged these together, I got 45. I then averaged these and I got 65, okay? So that's going to be my middles. And then I can draw my curve. Okay. So I need to come up with an equation for this. So I know it's going to start y equal. I'm going to do a cosine. This amplitude, it's 8 in either direction. So 8 cosine. And I know from here to here was 20, and here to here is 20. So my period is 40. Okay. So let me just jot that down. Period equals 40. So if I do 2 pi over b equals 40, I get 2 pi over 40 equals b, which is going to be pi over 20. And it's going to start at 35. So I'm going to go x minus 35. And then plus my 112. So that's my equation. So then it says, let me just move this. Then it says, what was the temperature when they first started timing? Okay, so basically we want to know what was it at 0. So I'm going to put 0 into this equation. Okay, so I'm typing in 8 cosine pi over 20, 0 minus 35, because we want to know the temperature when they first started timing, which would have been at 0. Make sure to close your parentheses, make sure your calculator's in radians. And we end up with 117.66, let's say degrees, 117.6. Then it says, find the first 3 temperatures after they started timing at which the temperature was 114. So if I was doing it on this calculator here, okay, I'm going to enter in 2 equations. I'm going to enter in this cosine one into my y equal, and I'm also going to enter in y equal 114. Okay, so let me get that in my calculator. So I went to my y equal, I put in my first equation, the cosine equation, okay, and then I want to know y equal 114. That's not one that I can see nicely on my graph, okay? So I'm going to go to window, I'm going to adjust my window. Let's say I start at, I'm up at 104, so let's say I start at maybe 100. Oh, sorry, that's my y. My x is going to be from 0 to, let's say, 80. Okay, from 0 to 80 by 5, so it's fine. Or we'll make it 10s, okay? Just so we don't have as many tick marks. And then we are going to have a low, it's 104 to 120. So let's say we go down to 100 and we go up to maybe 130. By, let's say, 10s. Okay. The scale just is going to have less tick marks depending on how you scale it. I'm going to hit graph. And so there's my graph. And then we're going to see the y equal 114. We want the first 3 times that happens. Okay. So in this case, if I'm doing it on the graphing calculator, I'm going to go to that trace button again for calculate. So I'm going to go second and calculate. I want 5 intersect, okay? Now, if I'm doing this, arrowing up and down jumps you from one graph to the other. So I usually am going to jump to the line. It's a little faster to travel on the line than on the sine or cosine graph. So I want to know where they cross. So I'm going to come here. I'm going to hit enter, second curve, enter, guess, enter. And then it's going to give me 3 point, let's say 5.7. Okay, so let me jot that down. So they wanted the first 3 times, okay? Now, what you don't want to do is think that you can add your period onto this, okay? So the period was, and actually this was in minutes, so I apologize. I wrote seconds, but this was in minutes, beginning of the last problem. The period was 40 minutes. So you can't add 40 onto this to get the next one, because if I added 40, okay, that would be putting me at the same spot on the graph. So I'm coming down here, that would be over here. This would be 40 more. So I can find that by adding 40. So let me just space this out. And this is my first one. 40 away from that will be here at the same spot. So that would be 43.57 minutes. This one here is going to, we can either find it, or you can also realize that if we know that this right here, okay, that right there, so let me just see that value. In this case, let's see. So if I know this value, I know that on both sides it is going to be the same distance, okay? Now this is actually happening earlier than my graph. So I don't really have that particular value here, but if I did, I know it's going to be the same distance on either side. So what I'm going to do is I am going to find this one the same way I just did. I'm going to go second and calc, back to intersect. I'm going to drop to the line. I'm going to come over here and I'm going to find this value. But again, if I knew this particular value, I know it's the same distance on either side. Hit enter, and it's 26.43, let's say 26.43. So 26.43 minutes. Now, if I needed a fourth one, okay, adding 40 minutes onto here would put me to this spot here, which is, again, I'm coming up, here I'm coming up, this is 40 away. These are not 40 away, so be careful with that. Okay, Last problem. Tarzan problem. So Tarzan is swinging back and forth on his grapevine. As he swings, he goes back and forth across the riverbank, going alternately over land and water. Jane decides to model mathematically his motion and starts her stopwatch. Let T be the number of seconds that the stopwatch reads, and let Y be the number of meters Tarzan is from the riverbank. Assume that Y varies sinusoidally with T, and that Y is that Y is positive when Tarzan is over water and negative when Tarzan is over land. Okay, so it's positive when he's over water, negative when he's over land. Jane finds that when T is 2, Tarzan is at the end of his swing, where Y is negative 23. She finds that when T is 5, he reaches the other end of his swing, and that is 17. So again, remember the negative was when he's over land. Okay, so he's 23 meters over land. Here he is 17 over water. Sketch the graph and write an equation expressing his distance from river bank in terms of T. Okay, so let me get my graph. Okay, so here's meters, here's seconds. I know that the highest value is going to be 17. So we're going to have 17. And the lowest value is going to be negative 23. So I'm going to go down to negative 23. And then what I'm going to do is I'm going to average these. So if I take negative 23 plus 17 and divide it by 2, I get negative 3. So that's where the middle is going to be. The middle is going to be at negative 3. I'm going to put that up a little bit higher. So you see that that's going to be a difference of 20 and a difference of 20. And let's put in some of the values we know. When T is 5, he reaches the end of the swing, which is 17. So I'm going to put 5 here. I'm going to actually write it above just because I've got that there. And so he is at 17. Now, hold on a second. When T is 2, he's at negative 23. Let me start again. So when T is 2, he is at negative 23. Okay, negative 23. And when T is 5, he's going to be at 17. Okay, so let me put 5 here. And he's going to be at 17. So that's going to be 3 away. Okay, so then if I go another 3, which would put me at 8, he is going to be at negative 23 again. Okay. And then in between those, okay, so when I average this, I'm going to get 7, which is 3.5, 13, which is 6.5. So let me just write those in. Okay, so I squeezed in my 3.5 and my 6.5, and that's where I'm going to have my medium, my middles, okay, and then I'm going to draw my curve, a little thicker. Okay. Start again. Okay. And so now I'm going to write an equation for this. So let me give myself some space here. So I'm going to have y equal, my amplitude is 20, but I'm starting at a low. So I'm going to put negative 20 cosine. And then I need to figure out my b. So I know that from here to here, okay, from here to here, this was 2 to 8, which is going to be 6. My period is 6. So I know that 2 pi over b equals 6. So that means that 2 pi over 6 equals b. So I get pi over 3. Pi over 3. And then I'm going to do x minus 2. And then minus 3. And that's going to be my equation. And then on these, and I put x, here, let me change it to t. I wanted it with t. So t minus. Okay, so I got my t in there. Okay, so now I'm going to be putting 2.8 in here. I'm going to put 6.3 in here, and I'm going to put 15 in here. Okay, so let me just get that in my calculator. So I actually put it into the y equal part of this just to show you something. And I adjusted the window, okay, to fit this data, but also to fit the values I need to find. So I needed to get to a 15. So I made sure that my graph would go to 15 in terms of my x's, okay? And I'm just gonna hit graph. And I can plug it in. I'm just going to show you another way to do it from the graph. So that same button that we got intersect and 0, there's also one that says value. So if I go second and calc value, as long as my x is here, so that's why I kind of extended it beyond what my graph was. My graph went to 8, but I needed to get to 15. So I made sure I would go beyond 15. I went to 20. So if I put a 2.8 here, it's going to show me where it is, and it's going to give me the y value. So negative 16.38, negative 16.38, okay. Second and calc again, value, and this time I want a 6.3, and I get a 1.16 if we round, 1.16. And then I'm going to put in a 15. Oops. And so I'm going to put in 15, and I get a negative 13. Okay, that one is a negative 13. Now it's asking us where was Tarzan when Jane started the stopwatch? So Jane started the stopwatch at 0. Okay, so I can do second and calc. I can go to number 2, second and calc. I want value. I want when my x is 0, okay? And that is at 7. Now, if I also let me get out of this. Let me get back to the graph again. If I hit trace, usually your trace button will take you to your y-intercept, and that's actually what I was looking for. So that's another way to get that value. So when was this, when did Jane start the stopwatch? At, where was he? 7, okay, 7 meters. So here, these are all meters, okay? So that's the worksheet for today. Your homework is going to be a worksheet very similar to this. So hopefully you'll find this helpful for that.